Sir, but I don't have any doubts in them.
Oh, all right. Okay, okay. All right. So then, okay. So then I'll do some questions. Okay. So applications of sine rule, cosine rule, and so on. Uh, no problem. We'll try to do something. Yeah. So, well, with this, so as we have seen, right, the sine rule, cosine rule, these are very useful uh, to relate the lengths with the angles. That's the there is a thing. Yeah. Maybe we can build this one result, which is maybe like this. Okay. So suppose that you have, so let's say that you have two lines. Okay, just two lines drawn randomly. Okay, and then you have this one source of light, and from there we are drawing four lines. This one will probably only be application of sine rule. Okay. Do we need four lines yet? Means, yeah, this is okay. Hmm. Now something interesting. A, B, C, D. Now let's say that this ABCD is in a very interesting ratio, and its ratio is like this. It's an interesting relation that AB by BC is equal to AD by CD. Yeah, I'm used to writing it like that. Let me write it like this. Now, used to meaning this is AD by CD. Okay. Yeah. So it's like this. It's like B divides AC internally in a certain ratio. Okay. And D divides AC externally in the same ratio. Okay. This is an interesting thing, right? And now you're just taking another line. So this is line L. Now we're just taking another line L prime, and we are doing the same thing. Okay. Same thing meaning we just want to find out. Okay. We want to say show the same thing holds. Okay? This is far from obvious maybe, right? Show that A prime B prime by C prime B prime okay. Now this is not a trivial result. It's probably will take a little bit work to prove, but I will first begin with a very simple version of this. Suppose I had this situation where the lines were parallel. Suppose that these two lines were parallel. In this case, can you provide me a proof? Anyone? Just try. Same question, but the lines are parallel. So AB by CB is same as AD by CD. And you want to show A prime by B prime. A prime B prime by C prime B prime is same as A prime D prime by C prime D prime.
So we can use similarity, right?
Yes. Here you can use similarity. Can you tell some details?
So all the angles will be equal, like OAB and OA dash B dash are equal
Mm-hmm.
as the lines are parallel, and OBA and OB dash A dash are also equal, and O is already the common angle.
Mm-hmm.
So the ratio of the sides is also the same.
That's right. So how will you use it?
So AB by CB should be A dash B dash by B dash C dash, right?
So you said it directly. That's nice. Okay. Yeah, because you can actually see it. So there's no reason not to, not to say it. Yeah. So this is not a theorem. And I mean, this one's something which you have to prove, right? But Aparna, are you okay with this? Are you able to say this directly?
Yes, sir.
Yeah, it should be, right? And it is. And if you really, because see, if you write this in an exam, maybe you can lose some marks. I don't know. Okay. So you can maybe then write, okay, AB by A prime B prime is equal to OA by OA prime, that is equal to OB by OB prime, and similarly you write that, and OB by OB prime connects them, and so on. So you see, in the case of parallel lines, actually this is equal to this, right? So we are getting something more, right? And similarly, obviously, this is equal to this. So then all four become equal. Do you see? Is it okay? We want to do the problem when the lines are not parallel. Now the problem becomes interesting. Or maybe I will ask another question, related question, so you get more into this kind of question, more into the groove. So yeah, let's say that I told you that this angle was equal to this angle. Fine, I mark that. And OD is the external angle bisector, by which I mean that so external angle bisector, you can understand like this angle is equal to this angle, which doesn't look like in the picture, but yeah. Now can you show this? So forget about this. So I'm trying to present you with a situation when this does happen. Okay. So these are like supporting questions for you to get the feel of the problem, and also just a general thing that when you get this problem and you cannot solve it, you can think of this approach, right? Solve similar questions. So you already know the angle bisector theorems, right? So why don't you use them? So what is the progress? What kind of help do you need? Where is it?
Sir, how can we apply the angle bisector theorem for the angle bisector OT?
So you are asking the external angle bisector theorem, right? So there is an external angle bisector theorem also, right? So the internal one we all know, but when I did the internal one, you should have asked me or gone back and I expected. That's okay. But yeah, when I read the internal angle bisector, I was determined to know the external one also somehow. No, I need to, and I somehow found it somewhere. I couldn't do it myself that time, but yeah, AB by BC is equal to OA by OC. This is something that you know, right? What should the external angle bisector theorem be? Any guesses? Ishana, even if you don't know, can you guess what the external angle bisector theorem should be? See, from what we have to prove, it should also be OA by OA by OC, right?
Yes.
That's what it should be, right? Now you just go and prove it. Simple. Just that, right? So this is homework. Okay, that when you have an external, so you have this angle AOC is the angle. You have the external. Here the B doesn't play a role. Okay, so you can simplify the picture. Draw the picture and then try to prove this. And tell me next time. Okay, then you can do the proof if needed. Okay, but this is the standard result. Then we are done. Now let us come back to this question. Okay, if this was internal bisector and this was external bisector, yeah, then our condition, because when you see this condition, then you would think, when does it happen, right? If you cannot solve this question, then that's the next thing to kind of think. Have I seen this? When can this happen? Then this happens when we have this situation. Okay, so this is the situation. Internal bisector, external bisector is messed up. This is external bisector, right? Okay, internal bisector, external bisector gives you that ratio. So for this case, you see the problem is done. So far we have not used any trigonometry. Okay, then is this done? Yes, because what's so special about this? Same thing. Do you agree? It is an internal angle bisector, internal and external bisectors for this things, OA prime, OB prime, and the same ratio will hold. Nice. Is it fine?
Yes.
Right?
Yes.
So this is the beautiful thing. This theorem is something actually deep, but the proof is easy thanks to sine law and cosine law. Only sine law probably this one. Now let us face the reality and come to the question. So far we're sort of trying to escape the question. And maybe today we will prove this external angle bisector also by sine law, and you will see it's very useful. Now let us start using the sine law. See, the goal for the sine law, what does it mean? We want to convert this information. See, what is the theorem telling you? That this fact that this AB, this ratio, yeah, this ratio on the ABCD points has something to do with the angles here. Do you agree? That is why you can take it anywhere with any other line L prime, right? So we take it to the angles. And this is a perfect recipe. This situation fits perfectly with the sine law, right? So let's start that. So what do you know by the sine law? So apply it on triangle OAB. So I'm doing this because I started doing this for the first time. But do anticipate the next steps and make sure you understand everything. OAB, then I'll write alpha, beta, gamma because otherwise you have to write a lot. And also maybe these angles are not going to be important. So X, Y, Z, and maybe also W. Okay. So on OAB, if you apply, then the real players are AB. So AB by sine alpha is equal to, what should I take? I'll take OB. I want to move to that triangle. OB by sine X let's also write this OA by sine. Is it okay if I write sine y? Okay, because 180 minus y and y sine is same. That's another good thing. Apply it on OBC now. I'm not writing OBC anymore. I'm just going to apply and write the equation. Sorry, yeah. Can you tell me what, anyone? OBC. Let's say BC, sine beta, OB, sine Z, OC by, is it correct? Yeah, OC by sine Y. Sorry. So what should we do? Should we write for gamma also? Right? Or then there is AD, and so maybe we have to write the OAD also. Right? So we have to write two more equations, right? Two more set of equations. Okay, I can see a cleaner from here, but so let's write CD. CD by sine alpha, right, is equal to, no, then there is one more equation. Let's write it. Should we write it? Yeah. AD by then it is what is it? OA by sine W. Like don't, because see, I don't get maybe there are a lot of equations, but we're just writing it. We don't have to remember them, right? Just writing it. We are using a theorem to prove another theorem, and we have seen special cases of that, and it's interesting. OD by sine X. What should we do now? We have to use that condition, right? AB by BC is equal to AD by CD. See, finally, we want to say that yeah, finally, we want to understand this in terms of alpha, beta, and gamma. We want to eliminate, simply put here, you want to eliminate X, Y, Z, and W because they are not going to be preserved. These are not cyclic or similar or anything. It's a random, L prime is just another random line, right? This angle, you don't want that. So how will you play the game? You don't want X, Y, Z, and W. Okay. Now you see, well, if you take these equations and simply try to eliminate X, Y, Z, and W, then you are bound to get an equation which contains A, B, B, C, C, D, A, D, C, D, and alpha, beta, gamma. Right? That is what will happen.
Sir, AB by BC is equal to OA by OC here, right? On the first two equations.
No. Why is it OA by OC? No, because AB by BC. No, that's a good observation, but it's not OA by OC. It is, and that gets us started. It is equal to sine alpha. No, no, that's what. Yeah,
Yeah.
that's the adjustment. You see, this also gives you a proof of the angle bisector theorem. When alpha is equal to beta.
Yes.
Aparna, is it making sense? Yeah. When
Yes.
alpha equal to beta. Yeah. Use this. You can use this kind of technique to prove the external angle bisector theorem also. Try it. Try the prove the external bisector theorem. But anyways, this is a good start. Similarly, you find AD by CD, a nice expression for that. And there it is, as clean as anything. Problem is solved almost. Right? You see how nice this theorem is. Yeah, it's not just a computational tool. We are not really computing anything. We are using this fundamental thing that this ratios of lengths is related to ratios of sines of angles, not angles. So angles are a very nice thing, but sines of angles are sometimes better things to deal with. Okay. So we get and this was a lemma that was also, I mean, I also used it in one IOQM question, I think. This this thing that, one second, so I say this. Yeah. So if you look at this finally, right, then what does it tell you? That this ratio AB by BC, so we can now completely forget this, and probably I can say it better then. Right? That this ratio AB by BC, right? Yeah, just look at this. Yeah, just look at this one first, right? This ratio AB by BC has to do with the ratio OA by OC and sine of the top angles, right? This is by itself a very important tool, right? To go from ratio of the sides there to ratio of the sides at the bottom, if you know the sines or whatever that's. Yeah. So this also tells you something interesting in this way, that maybe that yeah, maybe let me not say it. That's not very useful thing to say. That might actually be more confusing to say. So now you see the problem is solved, right? We see that AB by CB by AD by CD is a constant. Forget about all this. Forget about this. Okay, look at this. This is a constant. What that constant is, you can see on the board. Alpha, beta, right? But the point is that it's a constant. Obviously, it's a constant is a nice conclusion, elegant conclusion, but it passes via the sine rule. But now we know that it's a constant. Okay, so do you like this result, right? That AB by BC is not a constant, because why will it be a constant? I mean, right? I mean, if I change the line, By what do you mean by constant? I mean, it doesn't depend on the line L. So obviously, if you change the line L, AB by BC will change because it's not similarity. Similarity tells you that if you move it parallelly, then AB by BC is a constant, AD by DC is a constant. That is what similarity tells you. But now this is telling you that ratio of ratios is always a constant. Even if you don't have similarity. So this is like an extended version of similarity, but probably not useful way to think about it. But yeah. Is that point making sense, right? It's like the ratio of ratios is a constant. It only depends on the original source of light. It doesn't depend on the perspective. Doesn't depend on, like what angle you sort of, yeah, or it doesn't depend on where you're projecting it, right? What's the surface you're projecting? This ratio of ratios. Problem is done, right? Because we are given that this is 1, so it will remain 1 for this also, because it will depend. If you don't want to use the word constant, then just say that it depends on these angles. Sorry. Okay. So any questions in this? No. Right. So we will. Yeah, I wanted to say a few more things about this, but we will say it later. Later on, I will show you how the situation for parallel lines actually can be used to prove this version also. But that's yeah. You can try this experiment. Like if you take this situation, like draw it on a piece of paper, and then so you've drawn this situation on a piece of paper like this, right? Right. Oh, I can't see myself. Okay, I'm saying that you can draw it. You can draw the situation on a piece of paper, and then try to tilt the paper so that you cannot see the point O, or just change your perspective, right? So that you cannot see the point O. You can see everything else, but not the point O. In that situation, you will see that L and L prime will start to look parallel. Do you agree to this? No, you will not agree to this probably because it is not correct, right? In that situation, the 4 lines OA, OB, OC, and this, they will start to look parallel, right? Yeah. You can try to do this, and that can be yeah, that's the thing. And in that case, the proof is simple when these lines are parallel. Okay, but we'll yeah. Here is a homework. I'll probably say that later. But here is a homework that I want you to try. Yeah, where should I write it on a new page? I'll clear this thing. This is a homework. So there are 2 homeworks, okay? And yeah. Now we have 2 lines like this, okay? And we have 4 parallel. This is really, let's see how you do it. See, all these homeworks I'm giving you, you have to return it to me in the sense that you have to next day bring it up. Otherwise, see, I will not remember. And yeah, if I remember, I'll ask, but please take the responsibility to turn it up. Otherwise, yeah, otherwise gone. They are not equally spaced. That's not what I want to portray. They are not equal. Yeah, so now it looks equal. Like this, prove the same problem, do the same question. Now you cannot take the help of that angle because these are parallel. Yeah. do the same problem. So you can write it. Now these are parallel. Now it's probably a silly question, but let's do it. All right. So we'll move on. Yeah, I want to give another homework. So this is also related to, it's also straightforward application of law of sines, and it's a tremendously important theorem. Okay, but it's easy to prove, very, very easy to prove. So we know this result, and if you don't know it, let me see, then tell me that if there are these four, and there are these three what are called cVns, lines coming out from vertices. CVns is just a word here. Do you know what you can say about about this ratio BD by DC and so on?
Yes, sir, the Sivas theorem.
Yes, so Siva's theorem. Ishana, I have done this with you, right? I hope.
Yes.
Yeah. So this is a very important theorem. Somehow in IOQM, they tend to give more computational questions. So it's also useful in computational questions, but this time somehow I couldn't find an application this time. But this is a standard theorem. This we know. But I want you to prove an angular version of this, which is sometimes very, very useful. Okay. So show that. So again, I'll just label them like this. Gamma delta. You know, I'm just going cyclically. Zeta. What should be the symbol? Alpha, beta, gamma, delta, eta, eta, theta. Theta should have. Yeah, theta somehow seems like it's special. Yeah. So this is just is easy to remember. Also, meeting is going to end, so quickly just you understand what I'm asking, right? So it's all. Yeah. This ratio is 1. Sine. Note this down quickly, okay? Then we'll meet. Yep. Note down this is also homework. Since you guys are not doing problems, so okay, I mean, I understand there are reasons, so don't mind it. But yeah, then I'm giving these questions. All right. So I'm just waiting for a meeting to end. Then just